Welcome to Easy Elimo Learning Simplified. My name is Eric. I'll be taking you through the topic divisibility tests, and I'll be doing divisibility test for 11 for this lesson. So first we look at the divisibility test for 11, then we look at some of the problems involving the divisibility test for 11, and then at the end of the session we'll be able to give you some questions to help you with practicing, at least to help you check whether you've understood the concept that is being tested here. So what is the test for 11? How do you know that a number is divisible by 11? If you're just given a number at a glance, how would you be able to tell that this number is divisible by 11? So the test is as displayed on the screen. So this is the condition that you'll be able to check whether it is fulfilled or not, that a number is divisible by 11 if the difference between the sum of digits in alternate positions is either a 0 or is a number that is divisible by 11. So those numbers that are divisible by 11, we have 11 itself, we have 22, 33, and so on and so forth. So at least if you do the difference between the sum of digits in alternate position, you should be able to either get a 0 as the answer, or the answer should be a number that is divisible by 11. We have examples here, like 121. So alternate positions, if you pick this as the first one, that is 1, then you skip the next digit, you move to the other digit. And then the next one will be this. So you add 1 to 1, and then you subtract, because we are talking about the difference between the sum. So you add first digits in alternate position, meaning if you pick a digit like this one, you skip 1, you go to the next one. So you have 1 plus 1, and then you are subtracting 2, and you can see that the answer is 0. So if the answer is 0, then you know that that number is divisible by 11. Another good example is here. So if you pick 1 as the first one, then you skip 0, you go to 2, and you add. That is sum of. Remember, we're talking about the sum of digits in alternate positions, meaning you skip. If you pick the first one, you skip the second one, you go to the third one, and so on and so forth. Then now you start from the second one, you skip the third one, you go to the fourth. So you add that way, then you subtract the two, depending on which one is greater. You subtract in such a way that you end up with a positive value. So we have 1 plus 2, and then difference, meaning we subtract 0 plus 3. So this is going to give us 3 minus 3, and you can see that the answer is 0. So you can get a 0 as the answer, or a number that is divisible by 11. So all these supposed to be following the same pattern. So we have 121 here divisible by 11. We have this, we have this, we have 605. If you pick 605, you see, you skip 0, you move to 5, you sum them. So that is going to give you 11. So if you add this, you're getting so adding 6 to 5, we are getting 11. So 6, you add 5, the answer is 11. Then you have 0 in the middle. So 0, which is just 0. So that if you subtract 11 minus 0, the answer is going to be 11. And 11 is divisible by 11 once. And then that qualifies the number here, 605, to be divisible by 11. So we want to look at the first example here. And the example is by use of long division, we're supposed to prove that the following numbers are divisible by 11. So we'll not use the test here, but we'll use the long division method. So long division method is part of what you have covered in our previous video, and you can always check to see how that is done. So you do that. 11 is the divisor. 2332 here is the dividend. So you check whether 11 can divide 2, can go into 2, and you realize 2 is smaller. So I'll go for the first 2 digits. We said if the first digit is smaller than the divisor, then you go for the first 2. If the first 2 is still smaller, you can still proceed with the number formed with the first 3. So in this case, I'm going to use the first 2, which is 23. So 11 goes into 23 how many times? 2 times. And please take note of where we are writing that 2. We are writing it on top of the second digit of the 2. And then, of course, as we have discussed previously, you're supposed to multiply 2 by 11 to give us 22. And then the next thing that we're supposed to do is to do the subtraction, and that is giving us 1. That is 3 minus 2 is 1, and 2 minus 2 is 0. When 0 appears before the digit there, then it doesn't count that much, so you can as well ignore it. Then, of course, what you're supposed to do next after that is to drop the next digit down here, and that is giving us 13. So again, you ask yourself, 11 goes into 13 how many times? And you realize it just goes once. Take note of where I'm writing that 1 on top of the next digit 3. And then, of course, the procedure still remains. You multiply 1 by 11 to give you 11. And then, of course, you still have to subtract. 3 minus 1 is 2. When you subtract 1 from 1, the answer is 0. When 0 appears before the digit there, it doesn't count that much, so you can ignore it. So what you do next is to drop these 2 down here. And then now 11 goes into 22 how many times? 2. And 2 by 11 is 22. And the answer is, if you subtract, the answer is 0, 0. So you can see in this case, the remainder is 0. So we can say that the number 2332 is divisible by 11 because 11 goes into 2332 212 times without leaving any remainder. Every time we realize there is no remainder, then we say that the number here is divisible by 11. It is divisible by the divisor, so there is no remainder. So you see, by long division, we're able to prove that that number is divisible by 11 because it goes into, 11 goes into 2332 exact number of times without leaving any remainder. So the number is divisible by 11. So you say the number 2332 is divisible by 11. Take note of the reason, because 11 goes into 2332 exact number of times without leaving any remainder. Or you can alternatively say that the remainder is 0. The remainder is 0. So it means the number is divisible by 11. We want to attempt again B part of the question. So we have the division symbol here. So we have, that is B. We have the division symbol 11 outside, and then we have 5, 6, 9, 8. So again, you check whether 11 can divide 5, and you realize 5 is smaller, so that is not possible. So you go for the first 2 digits, the number formed by the first 2 digits, which is then 56. So 11 goes into 56 how many times? So 11 goes into 56 5 times, and 5 by 11, the rule is that you multiply the 2 after that. And take note of where we are writing that 5. It is written on top of the second digit of the 2. So 5 by 11, that is giving us 55. And if you subtract the 2, we have 1, and then you drop down 9 here. So the number formed after that is 19. Again, you check 11 goes into 19 how many times? And realize it's just once. So take note of where I'm writing 1 on top of the next digit, which is 9. On top of the next digit there. So again, you do the same thing, you multiply 1 multiplied by 11 to give us 11. So you do the same thing again, you subtract. You subtract this is 8. Remember, the reason why you're not subtracting this, because when you subtract this, the answer will be 0. 0 appearing before the digit does not really make any difference, so it doesn't count that much. You can easily ignore it. So you drop 8 again down here, and the number formed when you do that is 88. So again, you ask yourself, 11 goes into 88 how many times? And you realize that is 8 times, and 8 by 11 is 88. And you can see again, if you subtract, the remainder is 0. So because the remainder is 0, we can then conclude and say that the number 5,698 is divisible by 11. So please take note of the remainder. The reason why we are saying that the dividend here is divisible by the divisor, which is 11, is because of the remainder. So every time you realize that the remainder is 0, then you know that the number dividend is divisible by the divisor. So let's look at example number 2. Example number 2, where now we are supposed to use the divisibility test of 11 to prove that the following numbers are divisible by 11. So in this case, we are assuming that the numbers are, so we are just supposed to confirm. So But A here, we have the number 2332. So we're supposed to prove. So either, remember we already know the condition that is supposed to be met is that the difference between the sum of digits in alternate, so alternate positions, we have that. We have that. So the difference between the sum of digits in the alternate position should either be a 0 or should give us a number that is divisible by 11. So that is what we are looking for. So we want to try and test and see whether we are going to arrive at 0 or a number that is divisible by 11, like 22, 33, and 44, and so on and so forth. So we'll just check, is the difference 0? So if it's 0, we'll then conclude that the number is divisible by 11 because the difference between the sum of digits in alternate positions is a 0, because that is the condition that is there that we're supposed to check. So the first sum of digits is 2 plus 3. And then the difference, the other sum is 3 plus 2. And this is giving us 5. And then we are subtracting another 5. And the answer is 0. So you see the condition is met. So we say the sum of digits. So you write the sum, the difference. So you write the difference between the sum of digits in alternate position is a 0. So the number 2332 is divisible by 11. So already we have the condition met. So you have to restate the condition and say the difference between the sum of digits in alternate positions is a 0. So the number is divisible by, the number here is divisible by 11. You restate the condition. That is the condition that you are looking for. So in this case, it's met. What if it wasn't? So if it wasn't, you'd have still restated, but now you'd have said the difference between the sum of digits in alternate position is neither a 0 nor is a number that is divisible by. You see, so if you got something like 2, for example, you'd have said the difference between the sum of digits in alternate position is a 2, which is neither 0 nor is a number that is divisible by 11, and therefore the number is not divisible by 11. So in both cases, you still have to restate the condition. So you check whether the condition is met or not. Then now as you give your response, you still restate that condition. So let's go to part B. So we have the number 569. I mean 56. No, I think it's supposed to be part B of example 2. So we have the number here. So we have 509. We have 50929. So if you start with 5, you go to 9, and then from 9 you skip 2, you go to that. Then if you move to position number 2, you'll skip position number 3 and go to position number 4. Remember, as you sum them up. So we are adding 5 plus 9 plus 9, and then we are subtracting 0 plus 2. So the sum of digits in alternate position. When you start with the first one, you skip the second. When you go to the third one, you skip the fourth. Start with the second one. So we talk of odd positions and even positions. Odd positions and even positions. So this is giving us 23. 14 plus 9, 23. And then we are subtracting 2 to give us 22. So 22 here is divisible by 11. And remember, that is one of the conditions. So the conditions are either the difference should be a 0, or it should be giving us a number that is divisible by 22. So this is how we're going to put our answer. Just doing the subtraction alone is not enough. So you have to restate the condition in giving your response. So you will say the difference between the sum of digits in alternate positions is 22, and 22 is divisible. 22 is divisible by 11. So the number, so you restate the number again, 50929, that is 50,929 is divisible by 11. Is divisible by 11. So this is how you supposed to frame your answer. So you restate the condition that is given. Remember, the condition we're looking for is that the difference between the sum of digits in alternate positions should either be a 0 or should be a number that is divisible by 11. So we have done the difference, the subtraction of the sum of digits in alternate positions, and our answer is 22. So this 22 is one of the conditions that we're looking for. So then in restating the condition, we have to give evidence of our outcome. So our outcome is 22. It's not a 0. So the evidence we have is that the difference between the sum of digits in alternate positions is 22, and 22 is divisible by 11. So the number is divisible by 11. So this is how you're supposed to be framing our response. If such a question appears in one of the tests or even in an exam. So that is all for divisibility test for 11. Possibly there is a question here or a bit of a problem that you can try and solve to help you with practice and also to gauge your understanding of the concept. So you're supposed to state with reason which of the following numbers is not divisible.